All right, Tyler, so I wanted to film you with this project here. It's February, what is today? Let's see, February 6, 2018. And you've got your Capstone project as it is, and you're going to pick this back up later.
Correct.
Okay. And then you've got, just looking at the hardware here, we've got, you know, he's got a box, like a light box here, a tablet hanging on the back there with fiducials. And then a statue here. This is yours, right?
Correct.
And then Ricoh Theta camera right there. And then back here we've got a computer screen which is seeing a video through this webcam. And we've got an application up where, so you 3D scanned the statue. What do you call that statue, by the way?
Hand-carved wooden Buddha.
Hand-carved wooden Buddha, okay.
Which is something I've had for a few years. Interesting geometry to it, so that's why I used it.
Okay, I'm going to stop this for
Buddha.
Wooden Buddha. And you actually didn't 3D scan that with the Go scan, you used photogrammetry, correct?
I used a hybrid method, so it was a combination of photogrammetry and 3D scanning.
Okay.
So I used the photogrammetry to get the textures, the high-res details, and that, and then 3D scan it to get the scale, because you don't get that with photogrammetry.
Okay, that's cool. So you combined some pretty advanced digitization workflows then.
Yeah, it was a hybrid of what we use here in the lab. So.
Okay, so then we're seeing an augmentation of his output from that workflow you just talked about right here. So this is a virtual object that is actually here, but we're seeing it right there. Just so, you know, when people see this, that's an augmented reality right there. So then he has blue lights on right here.
So if I toggle different light sets here.
So one of the things that changed there was now it went from blue to yellow or kind of white lights. And what we're not seeing that well here through this camera is that the lighting actually changed on the object, which I'm going to shut the lights off in the lab here in a second. We'll actually go through each button.
Okay.
But he's using pipes down here. So this is a early beta test prototype of pipes. And go ahead and press one of the buttons and we'll just kind of... So you can see it actuates over the network right here. And Tyler's using some custom code to trigger that. Instead of the pipes as plug-in, he's just using the pipes manual control scripts, which are cool. All right, so now I'm going to shut the lights off, and we'll film the screen here. So again, I guess the whole purpose of this, if you want to articulate it, go ahead.
No. Wait.
Like the whole reason why do this was really to express lighting on virtual objects.
Yeah, so you have companies like Google coming out with these light approximation implementations, these technologies. And so what this is trying to prove is that virtual objects do look better when they're placed in a virtual environment that has similar lighting conditions to,
Well, yeah, so like Google, the AR Core, and you're talking about AR Kit and AR Core, they have light estimation,
Yes.
right? And that's based on just the camera's view into the virtual world and the 3D objects being in frame. But what you're using here is actually more of a holistic thing because you have the Ricoh Theta collecting a sphere, basically directional light.
Yeah, so you actually get the environment's light rather than just using the photosensors on a smartphone or something.
Or the video feed.
Yeah.
Right.
So this is just a closed test where this can be implemented is like in some type of cultural heritage museum setting.
Sure.
If you're trying to showcase a virtual object over distance of the real object, here you can
Right.
scan.
Yeah, because this workflow Tyler's using is Vuforia, which is an augmented reality workflow, which could be applied to like the Microsoft HoloLens or maybe next generation headsets that come out eventually. Because Vuforia is really rapid on their uptake on new AR systems. So it's using the image target back here in the back as the tracker to locate exactly where this virtual augmentation goes. So yeah, I mean, to do light estimation with a video feed, like say from this video camera, is one thing, but that video camera doesn't know that lighting looks different on the object coming from the side or the top or the back, So the Ricoh Theta collects a sphere, and then remaps the video from the theta onto that sphere, which gets used in terms of the lighting onto the virtual object. So now let's actually watch it in action here. So I'm going to stop the camera. Okay, so now we got the lights out. And there's nothing on right now. And it's pretty much lit. The camera doesn't pick it up that well, but yeah, the tracking works pretty well. So you got that occlusion working because, how did that work actually? Oh yeah, never mind. You didn't have occlusion. I'm getting confused. I'm confusing myself because your hand appeared behind the object, but you were just showing me that it's a virtual object. When you
reacts. So if I block the front sensor on the Ricoh Theta, you can see we get shadows.
Oh, you're showing me the lighting. Okay.
Yeah.
Yeah. Cool.
So the occlusion would help in creating that sense of it being behind my hand at that
Right.
point.
Like this workflow still doesn't create shadows that are accurate on the object.
Correct.
Correct. Okay.
Because
All right.
it's using Unity skybox to use global illumination to light the scene. So,
Okay.
but as you can see, we go through. Let's start with this one.
Okay, we just saw the lighting update. And my camera's having a hard time seeing it that well, but it's getting pretty close. The coloration is not the same, but I mean, it definitely changed and updated. Okay. Very cool. That actually looks, I mean, it's getting closer.
And one of the limitations here.
So hold on, leave it on that blue on there for a second. I want to mention something here. So like if you guys look, any people watching this video, you can see that this side is more lit up. Just, it's more apparent from my own naked eye here looking at the screen, but this right side is more lit up because the light is actually coming from this side, and then it still is reflected here. And this is what light approximation will do, or cannot do, compared to like this workflow. So again, this is a hardware solution, but it's sort of a unique approach. Go ahead.
Yeah, and then the red light.
Yeah, we actually get a,
So you see the highlight. And it's
we actually get a change of coloration on this side. Okay, yeah, that's very cool. It's a neat rig. It proves that approaching a problem with hardware solutions isn't always the best, but it's not necessarily something that should be ignored, right? Because yeah, light estimation with AR setups, it's not going to get that direction, right?
correct.
Right. Well, I think my tour's here, so I'm going to let you go, man.